which we are going to see is the center of mass. So what is the center of mass? First of all, before going to see what is the center of mass, we can see what is a mass. Mass is the measure of body's resistance which changes with respect to motion. Body's resistance, measure of body's resistance to change the motion, or it's the measure of inertia of a body. For example, if the body was at rest, if we want to move a body or we want to push a body, table or anything, then we need what? We need to apply the force equal to the mass. So that is, we are saying that mass as a measure of body's resistance to change the motion. So we are if it is moving in the same direction, if we want to change the direction of a body's direction to move in another direction, we have to apply a force. So there also we have to know about the mass of the thing. So the mass is otherwise is a scalar quantity and it is a constant. Mass is a scalar quantity and the value of the mass is a constant. It will not change with respect to change of motion or change of the position of the particle. So if we consider a system, we all know that if a system means it may contains many particles. Each particle will have different masses and each particle's position will be different from the reference point. See, for example, if we consider this is a system of particle and in this system of particle we have different masses. So different particles. So this is the particle of mass m1. This is the first particle. This is the second particle with mass m2 and this is the third particle with mass m3 and this is the fourth particle with mass m4. So if we consider this as an origin and we can measure the distance. With respect to the origin, the distance between the origin and the mass m1 is taken as x1. It is taken as what? x1. And the distance between the particle m2, that is particle with mass m2 and origin, it is taken as x2. And then the distance between the particle of mass m3 and the origin, it is taken as x3. So system means it may consider system consists of many particles. Each particle will have a different masses and each particle will be at a different point, different position from the reference point. Then now if we consider the mass of this whole system, the mass of the whole system is equal to mass of the particle m1, mass with the particle m2, mass of the particle 3, that is m3, mass of the particle 4, it is m4. All the summation is equal to the mass of a system. So hence, if the mass of a entire particle of a system, we need to calculate the whole particle system, we have to, entire particle of system is concentrated at a particular point. All these masses are concentrated at a particular point. That particular point is called as center of mass. That's a particular center point is called as what? Center of mass. So for example, I will give you an example for a center of mass with two atoms. So we are taking a nucleus. That nucleus consists of two atoms. That is, we have a center point here, that is a reference point, and this is the atom 1 and this was the atom 2 which revolves around a orbit. Okay. So here this is the particle with the mass m1 and this was the particle mass m2. So the distance between the particle with mass m1 is taken as x1 and the distance between the particle with mass m2 is taken as x2. So this is the thing. Now we can see an example, that is the whole body's mass. This mass of this whole body, that is two atom, is this is a system. The whole part we are considering it as a system. In this whole part, these two atoms have a different masses and different position. The atom mass of these atoms are concentrated at a particular point, and that point is this one. And here is this point, we are calling it as a center of mass. This point we are calling it as what? Center of mass. So we can see the definition for center of mass, that is system, it consists of many particles with different position and different masses. If the mass of this entire particle in a system is concentrated at a particular point, then that point is called center of mass of a system. See, for example, I am considering an fulcrum. Otherwise, we can say it as a seesaw. In the seesaw, we have n number of particles. That is, n number of particles are present on a seesaw. If the mass of this one, that is from a left end, the first particle is taken as m1. First particle has a mass m1 and second particle has a mass m2. And the right hand side at the same end, right hand side end, we have the particle with mass mn minus 1 and another particle with the mass mn. So this point center, the supporting point, or otherwise called as center of mass. This point is called a center of mass. How we can say that it is a center of mass? This position is a center of mass. That is the thing which we are going to see over here. The particle with mass m1 is at the distance of x1 with respect to the reference point, and the position of x2 with respect position of particle of mass m1 with respect to the reference point is considered as x2. Similarly, on right hand side we have a particle with mass mn minus 1. It was at a distance of xn minus 1 from the reference point, and also particle with mass m1 is at the distance of xn from the reference point. This is the thing which we have considered. So here this point we are calling it as a center of mass. Why we are calling it as a center of mass? How we can call it as a center of mass? How to specify that this part has a center of mass? That is the thing which we are going to see it over here. So here the position of mass m1, m2, m3, n minus b, we are considering it as x1, x2. That's the thing which we have told you. And the tendency of a mass to rotate. So that is the whole equilibrium. This whole seesaw may rotate only when the masses on both the sides are equal. When the masses on both the sides of the fulcrum are equal, that is, the tendency of a mass to rotate with respect to the origin or a supporting point is called as moment of mass. That we are calling it as what? Moment of mass. So, what is the moment of mass? We are going to calculate the moment of mass for a particle with a mass m1 with respect to a fulcrum. So if we calculate that, we all know that moment is a mass. The formula for a moment is the mass into distance. That is, mn is the mass and xn is the distance. So by this is the formula for moment of mass for an element with a mass m1. If both the sides of the equilibrium are equal, moments on the equilibrium, that is, for example, here we have a particle with mass m1 and the distance is x1, and the moment of this particle is taken as m1 x1, and moment of the particle m2 is taken as m2 x2, and moment on the right hand side it is taken as mn minus 1 into xn minus 1, and moment of mass with the particle mn with the mass of the particle mn, it is taken as mn into xn. This is the moment. So when it is said to be equilibrium, that is, if we calculate the total moment on the with respect to the fulcrum on both left hand side and right hand side can be written as mn x1, m2 x2 plus etc. up to mn xn is equal to the summation. The total momentum can be written as summation I equal to 1 to n mi xi. It is equal to 0. How we can say it is equal to 0? So here in the x-axis we can say that it is an positive x-axis. On the left hand side we can say that with respect to this origin it is negative x-axis. If we have minus 10 kgs on a momentum is minus 10 on left hand side, and right hand side will be, if it is equilibrium, it should be plus 10. Then we can say that total momentum is equal to 0. So if the total momentum is equal to 0, then the center of mass will lie at the supporting point. Here also, if this is the particle m1 with x1 and the second it is a particle with m2 x2, and then m1 x1 should be plus m2 x2 or equal to 0, or we can say that m1 x1 is equal to minus m2 x2. It is equal to what? Minus, that is the direction. This minus indicates the direction. Are you clear? And then, so this is that if both the sides of the in the momentum is equal to 0, then we can say that center of mass will lie at the supporting point of the system, and that is then we can say that the system is in an equilibrium position. Now, if the fulcrum is not at a balanced position, if for example here if we have a supporting point, and here if one person was sitting on a fulcrum, here there are two persons, then what happens to the fulcrum? Fulcrum will be moving in the lower, it will be not balanced, it will not be in a balanced position. So we need to adjust this supporting point to some distance to get a balanced position. That distance through which it is the fulcrum, our supporting point is shifted to get a balanced position is called that is called a center of mass. That we are calling it as what? Center of mass. How to calculate that? So under an equilibrium condition, if the total momentum, we can take it as summation I equal to 1 to n mi xi, then how much distance it should be moved to get a balanced position? It should be subtracted with the total momentum. So it minus summation I equal to 1 to n mi into this xi. That is the distance to which moved, it is equal to 0. Then we can equate these, that is we can bring this left minus to the right hand side. When we bring this, we get the equation summation I equal to 1 to n mi xi is equal to summation I equal to 1 to n mi into capital X. And then, so we need to calculate the value of x. So x is equal to summation I equal to 1 to n mi xi by summation I equal to 1 to n mi. So this is the momentum of system, and this summation of mi I is equal to 1 to n mi is the mass of a system. If the momentum and mass are known, we can calculate the distance through which the particle is to be moved to get a balanced position. So the distance moved to obtain an equilibrium position is called center of mass in one-dimensional system, and it is given by the formula x is equal to m1 x1 plus m2 x2 plus etc. by m1 plus m2 plus etc. So this is the formula to calculate the center of mass in a one-dimensional system. Next, the topic which we are going to see is center of mass in a three-dimensional system. We all know that three dimension means x, y and z axis. Here we are considering a system with the particles of masses m1, m2, m3 and position vectors, that is it should be compared with x-axis, y-axis and z-axis. So we are considering it as generally it as a position vectors r1. r1 is the position of the particle of mass m1, that is with respect to x-axis the position is at x1, and with respect to y-axis the particle's position is y1, with respect to z-axis the particle position is z2. Similarly we will have we will be having a position of a particle of mass m2 as r2 and position of the particle of mass m3 as r3. So we all know that center of mass along a one-dimensional system. What is the formula for one dimension? That is, with along an x-axis we have calculated x is equal to m1 x1 plus m2 x2 plus etc. up to mn xn divided by m1 plus m2 plus m3. So in the short form we can write it as summation I equal to 1 to n mi xi by summation I equal to 1 to n mi. This is the center of mass of a particle along x-axis. When it is compared to y-axis, similar to that. Instead of x, we will have y. So, summation I equal to 1 to n mi yi by summation I equal to 1 to n mi. And then, what is the center of mass along z-axis? So, z is equal to, similar to that, summation I equal to 1 to n mi zi divided by summation I equal to 1 to n mi. So in general, how we can write that? We have seen what is the center of mass along x-axis, y-axis and z-axis. So in a 3-dimension, we can't mention it as x, y and z separately. We need a single formula. So how to write that? So center of mass of a 3-dimensional system, it is taken as RCM, that is of x, y and z-axis. That is position vector with respect to the center of mass, and it is taken as summation I equal to 1 to n mi ri by summation I equal to 1 to n mi. That is the position vector ri. We all know that if it is a vector, xi I vector plus yi j vector plus zi k vector is the position vector in a 3-dimensional coordinate system.